in this problem, a particle of mass m is released from rest at point A, right? As shown in the figure, falling parallel to the vertical y-axis, right? This mass m is falling parallel to the vertical y-axis. Now you have to find the torque acting on A. You have to find the torque acting on this mass m at any time t with respect to origin, right? The second part, find the angular momentum of the particle at any time t about this origin, and so what is the angular momentum as a function of time, and third part is so that the relation tau is equal to dl by dt yields a correct result when applied to this problem. Now what is given in this problem? Now this is the mass of this body is m, and it is initially suspended orientally at a distance of x naught. So what force is acting here? The force acting is mg, right? Now with as the time increases, the force will be mg itself, but in no case its perpendicular distance being changed. So what will be tau? We have answer part A, this tau will be equal to what is r cross f, that is force into perpendicular distance. The force is mg, and what is perpendicular distance? All time it is x naught, right? All time it is x naught. So this tau will be equal to how much? mg x naught, right? This will be the answer to part A, right? अगर सपोज किसी इंस्टेंट ऑफ टाइम में हम इसको ये करें ऐसे, सपोज एट एनी इंस्टेंट ऑफ टाइम this mass is at this point, right? So this will be equal to mg, and suppose this is r, right? Now if this angle is theta, right? So perpendicular anytime what will be perpendicular? This will be the perpendicular distance. So this will be the r sin theta, and r sin theta will be equal to x naught. So इसका second method हम लोग ये कर सकते हैं कि this tau will be equal to r cross f, and this is r sin theta into f. So again it is r sin theta is always x naught, and f is mg, so it is mg into x naught. This will be the answer to the problem. Now B part, for angular momentum, what we see as the time passes, let it is the case after time t. So what will be velocity of the body? This body will acquire a velocity of v, which is equal to u plus gt, and initially u is 0, so 0 plus gt, so this v will be equal to gt, right? The velocity of the body at any time t will be equal to gt. So what will be angular momentum? Now this angular momentum L is equal to, this angular momentum L will be equal to how much? It is vector r cross p, linear momentum, and this is r cross p, that is rp sin theta, that is r sin theta into p is equal to mb. And what is the value of r sin theta? देखिए यहाँ पर मैं बता दिया हूँ. Now this is r sin theta. R sin theta is always equal to x naught. So this is x naught, and p will be equal to how much? P will be equal to m into v, that is m gt, right? So this will be the value of m x naught, m gt will be value of angular momentum, right? Now C part, clearly what we did, we will find dl by dt. So dl by dt will be equal to d by dt of what? D by dt of this mg x naught into t, right? Now this is the constant part, so it will come out. So this is mg x naught, it is mg naught, and d by dt of t will be equal to 1. So this will be mg x naught, and clearly it is equal to, देखिए यहाँ से tau is equal to mg naught, so this is equal to tau. So this will yield correct result.